Our next introducer of a keynote will be Tom Coughlin, who's president of Coughlin Associates. He's a digital storage analyst, and as opposed to the rock stars you've been seeing on those videos, I consider Tom a rock star in our industry as a technology consultant. He's the program chair of the 2022 Flash Memory Summit, and he was the FMS general chair for 10 years when we first started the conference. He has over 40 years in the data storage industry, in engineering, senior management positions at several companies. He consults and publishes market and technology reports and puts on digital storage-oriented events. He's a regular storage memory contributor if you read Forbes.com, and he's an IEEE fellow, chair of the consultants of the network of Silicon Valley, which meets frequently throughout the year, and he's a candidate for the IEEE president-elect this year. So with no further ado, I want to introduce Tom Coughlin, who's not only a colleague, but a very dear friend, to introduce our next speaker.
Thank you very much, Jay. So we have two speakers coming up here from SK hynix, Sanjay Talraja, who is Senior Vice President and General Manager of the Client Storage Group at Solidigm. So he heads their client storage group, and they're developing world-class and industry-leading storage products, especially for the PC segment. He's got over a 30-year career, and he's held a variety of technical and management positions, component system manufacturing, marketing, sales, and business development. So he's the general manager, and he leads a large cross-functional team that owns all aspects of the business from inception to high-volume manufacturing and working with major PC OEMs. He's also the author of 25 patents. Jung Dal Che is Executive Vice President and Head of NAND Development at SK hynix. And he oversees their 4D NAND development using 3D charge trap design paired with periphery under cell technology. And he began his work actually with EE circuit designs in 1986. He's been involved in development of a lot of types of memory since then. And he holds 183 US patents and has published 59 papers at well-respected IEEE conferences. He's been the general chairman for the International Memory Workshop, so he's been also very involved in IEEE. And it's my pleasure to have these guys come and talk to you about Solidigm. Thank you.
Good morning. Good afternoon. It's great to be here today in person at Flash Memory Summit, and I'm honored to be representing the team members at Solidigm and sharing the stage with my friend, Jay, who you'll hear from a little bit. Together, we're going to tell you the story about data and our collective insatiable appetite for data, and how SK and Solidigm are innovating together with our partners and customers for optimized data storage solutions for what we call as the data chasm. What do you mean when we say data chasm? Data chasm is the entire universe where data is created, it's stored, and it's consumed. The inhabitants of the data chasm, data, tends to have an extremely long life. At times, it may run a temperature and feel hot, or it may feel cold. It takes on different bodily forms, such as an SSD or an HDD, and at times it could be resting forever on tape. Talking about long life and resting on tape, recently I had the experience where a video of mine taken on a camcorder maybe 2 decades ago recently resurfaced on one of my birthdays. That was a video I thought was dead, but data lives on. The genesis of the data chasm as we know it today probably started in the mid-2000s with the advent of 3 different technologies. The multi-core CPU for the data center, server virtualization software, and of course the introduction of the very first commercially viable SSD, the X25M from Intel. These 3 technologies led to the development of scalable, reliable, and cost-effective data centers, and over time, it led to the launch of several large-scale cloud services. These cloud services were the watershed moment in the democratization of data. They spawned a virtuous cycle of innovation and created new business models in either content creation, productivity, e-commerce, and many more. We're still in the middle of that virtuous cycle that's continuing. It's driving the acceleration in creation, consumption, and capture and analysis of the data. That's even led to even more technological innovations and a further democratization of data. As we started on the data cosm, we just had one galaxy, what we refer to as the compute galaxy. In the compute galaxy, the CPU was the sun, and the data kind of revolved all around the CPU. The strong gravitational pull of the CPU tended to pull the data as close to it as possible, most of the time connected by a local bus that enabled rapid data transfer. But we're now having two megatrends that are taking place that are altering and having a dramatic impact on the data cosm, but also our lives. The first trend is AI, or artificial intelligence. Actually, AI has been around for a really long time. We're just starting to see the commercial realization of AI, and that is being made possible because of the cost-effective ability to store, analyze, process, and real-time move large unstructured data sets. For example, a connected car today probably connects with about 25 gigabytes of data an hour. As it goes to higher levels of autonomy, that data size could be growing to terabytes an hour or tens of terabytes a day. That's a large data set. And one of the key things making that possible is the NAND SSD. The second trend, the second mega trend, is the ubiquitous fast connectivity of 5G. 5G represents a new leap forward in greater data democratization and increased machine-to-machine data exchanges. IDC estimates that by about 2025, we're going to have about 75 billion connected devices, each of them creating and sharing data. A huge magnitude of data. With 5G, that also has the potential to be 100 times faster than 4G. That will make data access almost instantaneous, anytime, anywhere. AI and 5G are now helping create huge data masses with strong gravitational pulls by themselves. This now is then creating a second galaxy in the data cosm. We refer to that as the storage galaxy. Now, the compute galaxy with storage near compute, storage galaxy with compute near storage is great. It actually leads to less interstellar travel, which is good from a cost effectiveness and efficiencies perspective. But what it's also doing, it's creating a different requirements for solutions that may be applied in the data center, in the enterprise, the cloud, or the edge. As we navigate these changing requirements in Solidigm, we strive to be your trusted partner to deliver optimized storage solutions for both the galaxies in the data cosm. Now, to hear a little bit more about Solidigm, let's take a look at a short video from our CEO, Rob Crook.
Insatiable data consumption is the wind at our backs. We have the talent, world-class inventors, leaders, and problem solvers from Intel, SK hynix, and more. We have the track record. SK hynix has thrived in the incredibly competitive DRAM space, and Intel's memory business has delivered key industry advances. Together, we carry this innovative leadership forward into the new opportunities ahead. We have the portfolio with a unique set of leading-edge technologies. This enables us to meet our customers' needs and optimize for our partners, putting us in a strong position to win. Our goal, become the #1 NAND leader by 2030.
Thank you, Rob. As Rob highlighted, with our customers and partners, we're tackling new challenges. We're defining new ways to capture and store the data, to move and process the data at scale and speed. Now, you've heard me use the word optimized data storage solutions. What do I really mean when I say optimized storage solutions? Our solutions are built on several layers of innovation. At the foundational level is the NAND component, with access to two different technologies, the charge trap flash that's optimized for performance, the floating gate flash that's optimized for capacity. We are uniquely positioned in the industry to deploy the right cell for the right use. Built on NAND brings in the SoC or the hardware layer. And once again, a good avenue for innovation like the EDSFF form factor that had its genesis in the ruler form factor, an innovation by Intel SSD Group in 2017. That form factor provides better manageability, serviceability, and thermal control for the data center. Built on that comes another couple of layers with firmware and software that can then be tuned to provide a high degree of customization and personalization for the data center solutions. Let's look at how these layers can really be applied in the real world in the data center. As most of the people, oops, it forwarded too much, sorry. Most of the SSD vendors today really deploy solutions and architect solutions for what we call as the four corners of performance: the sequential read, the sequential write, the random read, and the random write. The real world actually lies somewhere in between. At Solidigm, we want to architect and design our products that have the performance and responsiveness in a place that really matters in the real world. A one-size solution does not fit all. Let's look at a couple of examples. For example, a workload in online transaction processing or e-commerce or cloud compute, that tends to have predominantly a random access characteristics, low transfer sizes with a read-write ratio of about 70-30. If you contrast that to the workloads that are in the AI pipeline, that could be all over the place. You could have a sequential workload that is 100% reads, move to writes depending on the stage of the pipeline, or it could be mixed and random. There are a variety of such workloads out there in the real world, and it is really necessary for the storage solution to be customizable to deliver the best performance for those workloads, such as the Solidigm D7 P5520 SSD, which is really built with intent and optimized for a variety of data center workloads. Let's take a look at how it does in the real world. Compare the D7 P5520 compared to competitive SSDs in the same class in a cloud compute workload where we just talked about it's predominantly 70-30 read. The fast reads and the media-assisted features for quality of service helps us deliver a better response time to the tune up to 39% and a 31% better throughput. In a different workload, like server-based storage, where a virtual machine very typically reads the data randomly and sends it to storage sequentially, the 5520 demonstrates up to a 15% better read IOPS and 11% better write throughput. And then the same situation holds for a couple of other workloads, like the general purpose server or data pipeline with big data analytics. The 5520 continues to shine over its competition in the same class from anywhere between almost 10% to 24%. But the real world is not just a single user environment. It's more multi-tenant operations. What that really means, it has multi-threaded concurrent operations with a lot of write pressure in the background. And it is critical for the SSDs to be responsive during these situations under load. The firmware and media innovations in the 5520 help it deliver a superior quality of service under these conditions. As you can see in the 4K byte and an 8K byte random read situation, the 5520 delivers a 40% lower latency relative to a competitive drive in the same class. Now I want to like to share with you some thoughts from one of our long-term partners, Vast Data.
5 years or so, new types of workloads have begun to emerge, typically referenced as AI workloads, artificial intelligence, also machine learning and deep learning, all under that AI umbrella. And these workloads are desperate for massively scalable storage systems that can deliver high performance at the same time. And that's where VAST has come into the picture. We take advantage of persistent memory to build a massively scalable write buffer, and then on the back end of the system, we're leveraging Solidigm's QLC flash, which is incredibly reliable, very resilient, and very, very low cost. And that's what allows us to really go after the hard drive with a vengeance. Solidigm QLC flash is the key ingredient in terms of being able to drive costs down for an all-flash experience.
Thank you, Michael. Now let's move from the data center over to the client space. In the client space, we've extensively studied the characteristics or the requirements to make a highly responsive drive. It's not just one number for performance and responsiveness, it's highly workload dependent. It matters on how bursty the access is, how much random reads there are, and we've kind of optimized solutions for what really matters in the real world as well for the client space. We all go along and innovating in traditional areas of firmware. Generation to generation, we see large improvements, but now we're looking beyond the traditional improvements to something that's more revolutionary in the NAND SSD optimization. And that's where we're now going into software. Built on over a decade of software excellence, the Solidigm Synergy software is another layer of optimization. With addition of learning algorithms that work hand in hand in conjunction with the SSD firmware, software delivers an enhanced responsiveness to the user. Not just storage responsiveness, but actually system responsiveness, where you can kind of see the PC Mark benchmark, which is a system score, improve, or the game load times are shorter when the Solidigm Synergy software works on the Solidigm P41 Plus SSD, a brand new SSD that we launched this morning. A big factor in delivering that performance is consistency. When we all buy a new SSD, it's great when it works right out of the box. The performance is good, but when we use the SSD for what it's meant for and start filling it up with data, the performance tends to degrade. It's important that we retain that out-of-box performance over the life of the SSD. And you can see here with the Solidigm Synergy software enables an out-of-box performance even as the drive fills up. Not just at time zero, but consistently over time, that high performance is maintained. Our customers recognize the need for optimized solutions as we partner with them to co-create. As reflected in the words from a couple of our valued partners, innovating with Solidigm enables them to deliver optimized solutions for their customers. Thank you, Mr. Su and Mr. Zaretsky. Now to talk about innovation at the foundational level of the NAND component, I'm going to turn it over to my friend, Jung-Dal Che.
Thank you, Sanjay. Good afternoon, ladies and gentlemen. My name is Jung-Dal Che. I oversee NAND flash development at SK hynix. Today, I am very happy to introduce evolutionary and revolutionary 4D NAND, which we have been developing at SK hynix. Our 4D NAND was first developed in 2018. Since then, all three generations have successfully entered to the mass production plant, delivering 35% bit growth and a further 10% performance enhancement per generation. With this 4D NAND, we can provide a better price and best performance and best quality to our customers. Such continued success was enabled by key technologies, which I will introduce in the following slide. The first of these is the sideways source architecture, which was first developed by SK hynix. It has the advantage of most suitable to the multi-plug 3D NAND because of much less dependency on lithography alignment than other conventional structures. Second, all periphery undercell. This enables an almost 30% chip size reduction. In 3 generations, we can place all periphery on the smaller cell array thanks to our innovative layout optimization. Third is the advanced charge trap flash technology that functions as the beating heart of 4D NAND. We have now secured a wider cell distribution window by continually refining CTF, as shown in here, and with the material and process optimization. Using these 3 technologies shown here, we are delivering the best yield and best quality 4D NAND. By consistently implementing design for manufacturing, inline process control, and machine learning, we are able to enhance the quality level to the less than 25 defect ppm. This explains how we are receiving best-in-class evaluations from our several customers, as shown in here. However, we are not be satisfied with such result, and we will strive toward ever improving quality. Along with this and the advancement, as of today, in here, for the first time, and let me announce successful development of our post-4D NAND, which is the world's tallest and smallest 238-layer 512 gigabit TLC NAND. As shown in this type photo, no spilling out periphery on the cell array was realized again, with a 30% reduction, even in the 512 gigabit density. Thereby, we can achieve 34% bit growth again. Also, when it comes to performance, this product achieves 50% fast I/O and 10% higher program speed and 21% better read power efficiency than our previous technology. About performance innovation, I'd like to introduce more in the next slide. Also, when it comes to performance and as you can see in this graph, in our 4th-generation 4D NAND, we have delivered nearly 10% better TLC and SLC performance every generation, which was enabled by advanced core architecture, entire process and design optimization. We will keep this trend, this performance trend, in the future. With the continuous enhancement to the 4D NAND, we have also readied the QLC lineup. Our latest is the 176-layer 1 terabit QLC, and which was delivered commercial samples since last June. And we will start mass production from fourth quarter for this year with the performance spec as shown in here. Based on 176-layer CTF QLC technology, we are developing 238-layer QLC that can be used in mobile product as well. As you know, we recently acquired Intel's NAND SSD business. Combining CTF performance with floating gate capacity, we will be able to serve the full range of possible applications from mobile to nearline HDD. So we expect to see strong synergy between CTF and floating gate NAND in the future. So I'd like to introduce successful development of our first floating gate QLC product, which is 192-layer 1.3 terabit QLC NAND for SSD application. It has 2.5 times faster program, 5 times better random read, and 1.5 times better read latency than our first 64-layer QLC product. Furthermore, I am very happy to announce and draw your attention world's first PLC NAND today. As shown in this figure, we can achieve 25% more bit growth than 192-layer QLC NAND. And the data retention after 1K programming rate cycle can meet the same level as the QLC product. You can learn more about the PLC SSD in our booth. Now I'd like to introduce our future revolutionary second generation 4D NAND. So far, NAND companies have focused simply on stacking. I believe we must innovate now to sustain the industry together and take a 4D NAND platform as far as we can. We are developing a second generation 4D NAND with 3 revolutionary technology. First, by increasing loads by more than 25 in a cell array, we can significantly reduce the cell overhead. Second, using a shared V9 architecture, we can achieve 30% less stacking and lateral scaling. Third, by creating new multi-site cells capable of extreme multi-bit operations and also faster performance. Therefore, our second generation 4D NAND will be an essential part of SK hynix future roadmap. This slide shows future 4D NAND technology roadmap of SK hynix. As you can see, SK hynix first generation 4D NAND started with 96 layers and has evolved successfully to higher stacks. By continuing to develop a new second generation 4D NAND, which has extreme lateral scaling and extreme multi-bit, SK hynix will forge a revolutionary path toward the best quality and performance for the next decade and beyond. I think our growth is driven by your support and your feedback and collaboration. That makes it our priority to seek shared growth without our customers and the business partners. This is the end of my presentation, and let me call Sanjay out to show our 2 outstanding technologies this year. Okay. This is very small, and I think I am tallest among the today presentation. This is the tallest, smallest, fastest, and the 512 gigabit 4D NAND. So, and come to Thank you. Thank you so much. Come to our booth for the closed discovery. And then,
Good one.
yeah.
You might be wondering what we have here in the corner of the stage. That is the world's first working PLC, or 5 bits per cell SSD. The presentation that you all saw that Mr. Shea and myself did was loaded and sourced from that SSD to the system and displayed here. The world's first PLC working sample of a 5 bits per cell SSD. Thank you very much.
Thank you so much. Thank you so much, and you will continue the sport.
Thank you.